Okay, so we've got yet another word problem, and it says a ladder is resting against a wall. The top of the ladder touches the wall at a height of 18 feet, and it asks us to find the length of the ladder if the length is 6 feet more than its distance from the wall. So we've read the problem. Now it's time to make a sketch. So let's see here. Here's my building. All right. And here's the ladder. And I'm not an artist. I've never claimed to be, and I certainly don't play one on TV. So there's my ladder. It's resting up against this wall, and let's just call this the ground right here. And let me extend the ladder. Not perfect, but it'll do. As they say, it's good enough for government work. Okay. So here's the ladder. We're resting it up against a wall. I don't know, maybe you're into building walls. It seems these days that that's all we're doing, building walls. All right, so we're building a wall. Let's see how high. It's 18 feet high. So let me label that in my diagram. And what else do I know here? Okay, let's see. The top of the ladder touches it at 18 feet. I've written that down. Find the length of the ladder. If the length is 6 feet more than its distance from the wall. So let's call this the distance, right? And the length of the ladder happens to be 6 feet more. So it's d plus 6. So there it is. D plus 6 is the length of the ladder. And again, we're assuming we're in a perfect world. Everything, the ground is perpendicular to the building, and so it's formed a right angle. Well, guess what? We have a right triangle. Okay, we have a right triangle. And what do we know about right triangles? Well, we know this. The sum of the side squares, the sum of the square of the sides, is equal to the square of the hypotenuse. A very famous theorem made famous by a little old guy by the name of Pythagoras of Samos. So Pythagoras came up with this grand idea. He said that if you square the two legs of a right triangle and you add those squares, that actually equals the square of the hypotenuse. So that's exactly what we're going to do. So let's identify here on our diagram. We've got A, we've got B, we've got C. Now we're going to write an equation now that we've assigned a variable D. Let's write an equation. 18 square plus D square equals D plus 6 square. So there we've got it. Now we just need to simplify it a little more. So what is 18 square? Doing that quick calculation in my head, looks like it's 324. 324 plus d squared equals, and guess what? A special product, a binomial squared. So let me expand this very quickly. D squared plus 12d plus 36, and there it is expanded. Now all I need to do is solve for d, and in order to do that, well, I've got a quadratic. Okay, let's start by moving this d squared to the other side. Uh-oh, what's happened? Well, as you can tell, the d squares cancel, and we're actually left with a very simple elementary two-step equation. Okay, so we've got 324 equals 12d plus 36. So all I'm going to do next is subtract 36. Subtract 36. Okay, so now I've got 324 minus 36. Quick calculation. That is 288 equals 12d. And my last step is to divide by 12. So what does that make d? So 288 divided by 12 is, you guessed it, 24 feet. All right, so there is the distance, but let's go back to the question. Find the length of the ladder. Well, we haven't quite answered that just yet. So this is 24 feet. So how long is the ladder? Well, 24 plus 6. The length of the ladder is 30 feet. So let's write that down. We have our answer. The ladder is 30 feet. Okay, so now we are fully prepared to build our wall, and we know exactly how to do it. We need a 30-foot ladder if we want to make our wall 18 feet high. So this may be very appropriate given what's going on in this country, but really I'm just making jokes. I'm not taking any kind of side here. Just thought it'd be funny since everyone's talking about building walls. So a good application again of quadratics, and as you can see, the quadratic part actually cancels out, but we got a good practice in with the binomial squared right here. So that's good.